In this video, we're going to talk about conditional probability. So conditional probability is the probability event 2 will occur given event 1 has already happened. So we will write conditional probability as this. Again, probability event 2 will occur given event 1 has already occurred. So let's take a look at a couple of examples. So what is the probability of selecting a 4 given the card is red? So we know the card is red. There are 26 red cards in a deck, and 2 of them are going to be 4s. So we're asking for the probability of a 4 given the card is red. So for us, we want to be able to take a look at the number of red 4s over the number of red cards. Well, how many red 4s are there? There's 2 of them, the 4 of hearts and the 4 of diamonds. And how many red cards are there? That is 26. And that simplifies down to 1 over 13. All right, let's take a look at another example. What is the probability that you will have 2 boys given at least one of the children is a boy? Well, how are we going to write this? The probability of 2 boys given at least one child is a boy. So for us, there's 3 different scenarios where you have at least one boy with 2 children. 2 boys, boy-girl, or girl-boy. So there are 3 different scenarios. So what are we thinking? It's the number of boy and then another boy over the number of at least one boy. Well, when we take a look at this, the number that are both boys is 1 out of a total of 3 different scenarios. So our basic conditional probability formula that we will use will be as follows. It will be equal to the cardinal number or the number of both event 2 and event 1 occurring all over the cardinal number of E1 occurring. Okay, let's take a look at a couple of examples. So a survey was given, should women in the armed forces be able to participate in active combat? So we have the gender, male and female, and their decisions between yes, no, and undecided. So first thing we're going to want to do when we take a look at this, I'm going to add up each column. 33 plus 40, that's 73 total yeses. 19 plus 8, that's 27 total no's. 4 plus 7, that's 11 total that are undecided. Add the total number of males, 33 plus 19 plus 4, that's 56 males, and 40 plus 8 plus 7, that's 55. Now, I can add the totals by taking 56 plus 55, which is 111, or take 73 plus 27 plus 11 is 111. Right? Okay, part A, what's the probability that the response will be yes? Notice this is not a conditional probability. It's just something I could have asked earlier in this chapter. So the probability of yes, well, the total number of yeses is 73. The total number of respondents is 111. So keep in mind, when we do each one of these examples, we're going to select one person's response at random. All right, let's take a look at part B. The probability the person said yes given the response was from a male. So now we're given a piece of information. So this is the probability of yes given the person is male. So this is an example of a conditional probability. So this will be the total number of yes and male divided by the total number of male. So how many are both yes and male? That's this number here. That's going to be 33. And the total number of males we've already added up. That's going to be 56. All right, part C, the probability the person is a female given the response is no. So this is the probability of female given the response is no. So we'll do the total number of female and no divided by the total number that responded no. So how many are both female and no? That's this 8 here. And the total no's was the 19 plus 8, that's 27. All right, let's take a look at part D. The probability the person said no given the response was female. So here the probability is no given female. Well, that's the total number of no and female over the total number of female. Now, keep in mind, the number that's no and female is exactly the same as the number of female and no. So that's still an 8. This time around, the female's 40 plus 8 plus 7, that's 55. So notice the order for the conditional probability that matters. So as a quick note, the probability of E2 given E1 doesn't always equal the probability of E1 given E2. Okay, couple more examples I want to take a look at. The probability that the person was undecided given the response was a female. So this is the probability of undecided given female. So that is writing it out as the total number of undecided and female divided by the number of female. So let's go back up. Undecided and female, that's this 7 here. And we've already done the female in the previous example. That's still 55. And then part F, the probability that the person was male given the person was undecided. So the probability of male given undecided. This is the same thing as the total number of male and undecided over the total number of undecided. All right, so let's go back up. The total number of male and undecided in this case is that 4. And the total undecided is 4 plus 7, that is 11.